Okay, good morning. I was hoping we'd be back in school by the time we got to naming and writing formulas, but we're not. So we're just going to have to make it work. So what we're going to do is for this week, this is Monday, we are going to learn how to name compounds. So, but essentially what we're doing is we're going to look at a formula and I'm going to teach you some rules, and these are the rules. All right, and I'll go through all these with you because I know they're not the easiest to read, um, as to how we know what to name things. On Wednesday, we're going to give you the name and then we're going to talk about how to write the formula. And Friday, all we're going to do is review all of this whole concept. So you got a week to sort of kind of get this thing down. You can watch this video as many times as you need to. But the rules never change. So the thing is about, you would, if we were in class right now, you would walk into my room and this whole thing would be filled up on one board. I had to condense it down to fit on this little board to do it this way. So hopefully it'll be okay. But the point of what we're trying to do is we're going to go through rules about how to name binary compounds. Now, binary just means two things, and that's all we're doing. We're not going to do anything more complex than that. Chemistry gets a lot uglier than that. But that's all that we're going to do. So we're going to focus today on naming compounds. All right. Again, I can't stress this enough. Watch this video today, watch this video tomorrow. I know Tuesday's not an e-learning day, but just trust me on this one. It'll help you out. All right. In order to do this, you have to be given the formula. So if you look down here, I have examples of formulas here. I have examples of formulas here. I have examples of formulas here. These are what you're going to be given. Okay. And then these are going to be the rules that you have to follow to name the compounds correctly. Now, we're not going to go into anything too terribly big. The hate box thing we talked about in class, we're skipping. I'm not going to worry about that at this point. It's just too much for you guys to do without me here to guide you. But the idea here is we're going to try to learn how to name two things. That's it. Just two things. So what do we look for? Well, we got three main categories. We have the ionic bonds, which remember are the positive negative attraction that holds them together. So they have their own set of rules. We have the molecular bonds. These are going to be those covalent bonds where they shared and play nice. And then we have something called acids, which are a special kind of ionic thing with hydrogen is going to be out in front. And we'll talk about that when we get to it. Okay. So your job is to look at a formula and just write out really well here and say, okay, what kind of formula is it going to be? What kind of category? Is it going to be ionic? Is it going to be molecular? Or is it going to be acidic? Is it going to be an acid? Okay. So remember, we're trying to name two things here. If it's ionic, what you're going to see is you're going to have your lovely periodic table, like you always have, whatever, and you're going to see a metal and a non-metal, something from the left of your periodic table, something from the left of the periodic table combined with something from the right on the periodic table. Okay. You also might see three or more elements. And this is when you guys get mad at me a little bit. And you're like, well, Mr. Kanye, you just said this was two things. And I get it. But if you remember what we did on Friday, those polyatomic ions, those things that act together and combine as one thing and then travel around, they might be in this category or whatever. This is why they're called polyatomic ions. Okay. And so if you look back to this chart that you have here, remember it's talking about having ions. So this is going to fit in this category as well. Here are your rules. Plain and simple, nothing terribly big. If you make them harder, you're going to get hurt. So don't do that. Okay, just follow the rules. First thing we're going to do is we're going to name the first thing that's there, typically the metal. We're going to name whatever it is. Okay. Then you're going to name the second thing, but you're going to have an IDE ending on it. You're going to change the ending of the word of the non-metal that's there. You're going to change that ending to IDE. And that's it. Okay. That's all you had to do. Now I have a star here. It says if three or more elements are there, right? If you're in this little subcategory here, you have to name the polyatomic ion, and we just don't change those endings. We leave those endings alone. Okay. So what do I mean by this? You're going to be given, remember, you're going to be given the formula. So you're going to be given things like this. Okay. I look at Na and Cl. I'm going to try to follow my rules. I want you to think about how you would attack this. Here is Na. It's a metal. Here is Cl. It's a non-metal. Okay. Metal and a non-metal. Metal and a non-metal. We're going to name the first one. This one is sodium. All right. And so you would just write sodium. Cl, you look up, is chlorine, but we changed the ending to IDE. And so this is just sodium chloride, table salt. That's all it is. That's how to name an ionic compound. Don't make it harder than it is. Okay, I promise. Okay. So here's MgCl2. Mg is over here. It's a metal. Cl again is over here. It's a nonmetal. So I have a metal and a nonmetal. And so I name the first one magnesium. So I'm just writing it down. This is what I want you guys to write on your papers or whatever. And Cl, chlorine, but we changed the ending to IDE. And so it's just chloride. Well, Mr. Connie, what about the two? What about it? There's nothing in the rules here that talks about using the two. You literally just name it. The name of this is magnesium chloride, done. Don't make it harder than it is. Don't put yourself into a situation where it's going to be harder than it is for you guys to do that. Okay. So what about this one? Na2SO4. Man, we got stuff all over the place, but let's count. We have 1, 2, 3 different elements here. 3 or more elements. Still fits in this category. So the rule is this. We have to find what 2 things we have. So sodium is the first thing, and SO4 is going to be the second thing. I name my first thing, sodium. Then I name my SO4. Everything we're going to do, even though it has 3 elements in it, is going to be 2 things. Name the first one, name the second one every single time. Okay? So Na is sodium, like we did in the first example. So let's put it right there. Then we got to look up SO4. SO4 is down here. All right, it's right here. It is sulfate. Leave the ending of that polyatomic ion alone. So this would just be sodium sulfate. And done. And that's all you got to do. I'm not making you memorize this thing by any stretch of the imagination. You just got to find it. SO4 is on here, so you got to find this thing. That's going to take some practice. Getting used to know when you look for things and when you don't and things like that. Okay? Excuse me. That's your ionic rules. Name the first one. Name the second one, IDE ending. Or if a polyatomic ion is involved, you leave the ending alone. Okay? So I'm going to get rid of these so I can have some more space to write some stuff here. That's your ionic, metal, non-metal. Molecular, 2 nonmetals coming together. We're going to name the first one. Then we're going to name the second one with an IDE ending. And you're saying, Mr. Connie, that's the same rules you have here. And I know it is. I don't shoot the messenger. I didn't make them up. Those are the exact same rules. So how do I know the difference between this one and this one? Here, you must use prefixes. My good English students, prefixes are things that go before words. All right, to let you know how many of them you have. All right. Now, if you see twos and things and stuff like that along the way, you got to tell me what they are. Here, you didn't. That was the difference. Here, you just name the first one, name the second one, done. Here, we got to use prefixes. So what prefixes do we have to use? Mono for 1, di for 2, tri for 3, tetra for 4. So you guys ever played Tetris? It got those 4 pieces. Penta is 5, like pentagon, hexagons, hepta, 7, octa is 8, nona is 9, and deca is 10. Okay, I know these aren't the easiest to read for you guys to see this while I'm going through this. So again, you can rewind this and play it again to your heart's content. I would definitely have all these rules written down as much as possible. Okay, right in front of me. And we have another little star, another little rule here. It says no mono for the first one. We don't use mono for this one. Now, you guys know these rules. I know you guys don't think you know these rules. All right. But you exhale this every day. You guys know what we call that? We call this carbon dioxide. Get it right. Carbon dioxide. Okay. Am I following the rules? Like, I mean, hopefully you understand that CO2 is carbon dioxide. I'm following the rules. All right. I'm going to name the first, C is carbon. I'm going to name the second with an IDE ending, oxygen, turns into oxide. And again, if you don't spell it all perfectly, it's okay. Oxide is the oxide part. And we have 2 of them. So we use di. Now, we only have 1 of the carbons. We're lazy. We don't write ones. But we don't use mono for the first one. Okay. We just don't do that. All right. So let's try a couple. Here's CO. What would you think CO would be called? You could die of it. It's really poisonous. All right. I'm going to name the first, carbon. I'm going to name the second with an IDE ending. And I'm going to use prefixes. Well, there's only 1 carbon. I don't use mono for the first one. There's only 1 oxygen. That's why this is called carbon monoxide, like carbon monoxide poisoning. Okay. So just follow the rules. Okay. I'm not trying to hurt you. N2O7. What do you think that would be? N2O7. Well, then name the first one, nitrogen. Name the second one. Here's oxide again. Now, there's two nitrogens. There's di. Mr. Connie, you said you can't. No. We only know mono for the first one. We can use di for the second one. Sorry, I'm right at an angle. All right. And for 7 is hepta. And so we would just call this heptaoxide, dinitrogen heptaoxide. So if you ever look at like ingredients bottles on food and things like that, that's why you got all those dyes and tris and all that kind of stuff along the way here. Okay. CCl4, again, carbon and chloride. I guess I should kind of backtrack a little bit. How do I know these are ionic or are not ionic? See, C and Cl are both to the right of that stair-step line. They're both in the non-metals category. N and O are both to the right of that stair-step line. So we're dealing with two non-metals here versus a metal and non-metal that we dealt with before. Okay, so there's my first, there's my second. I only have one carbon. I don't use mono for the first one. I have 4. So this would be carbon tetrachloride, one of the most important things in organic chemistry. Okay, and that's all that is. That's the rules for molecular. Now, the third one's hard. You can't sugarcoat any better than that. All right. Third one is a special type of compound called acids. And these simply have H's in front, not HGs. So if you see like this, Hg is mercury, it's not hydrogen. So that would fit in this ionic category because mercury is a metal. Okay, and again, we're not going to talk about the hate box. I'm not going to worry about that too much. Just name them like they are. So if you see an H in front, like HCl, I'm going to try to turn this just a little bit, just make it a little easier for you guys to see. All right, you have HCl, H in front, HC2O3, C2H3, I can't write this down. H3O2, I was in a hurry, sorry. All right. Anyway, I have an H in front, so it's in this acid category. If you do see that, H in front, then you gotta look for an oxygen, no O or with an O, okay? So if there's no O, like this one, HCl does not have any oxygen in it. My rules are this. I'm gonna write the word hydro. I'm gonna just write in big so you guys can see this. I'm gonna name the element that's with it. Cl is chlorine. I'm gonna change the ending to IC now instead of like IDE. So this becomes chloric. And then this is the word acid. Because I'm gonna write the word acid in number 3. So we're gonna write the word hydro. We're gonna write the element name with IC, and I'm gonna write the word acid. 3 steps. So what do you think HBr would be? I'm still gonna have hydro because there's no O. Except now this is going to be bromic because bromine changes to IC. That's all that is, okay? Come back here for this. Now, what about if there's an oxygen with it? If there's an oxygen with it, it means you have one of these polyatomic ions, one of these big nasty ones down at the bottom. So we do not use hydro. And again, don't shoot the messenger, just the naming rules. We don't use hydro. All we want to do is we want to name whatever polyatomic ion. We got to find it on here, not memorizing it, finding it. If it's got an ATE ending, we're going to change it to IC. If it's got an ITE ending, we're going to change it to OUS. And we're going to write the word acid. So I look up the correct form. Here's my H in front, so I know it's an acid. I'm going to look up this thing because it's got an O in it. So you look in your chart, C2H3O2 is the acetate ion. Okay? That's what you see on your chart. It's the very first one right up here. Okay? So what I'm going to do for this is I'm going to name it. But I'm going to change the ending. ATE changes to IC. So this is acetic. And I'm going to write the word acid. Otherwise known as vinegar. Acetic acid. Okay? It's vinegar. That's all it is. Okay? So another example we could do, because it doesn't matter, is like H2SO4. There's my H in front, so it's an acid. So I got to name this thing. Well, if you look on that thing, it's sulfate, right? SO4. Not making this up here. SO4. Where's my sulfate? Right here. Sulfate, SO4. Okay. So I'm going to write that down, except I'm going to change the ending to IC and call it sulfuric acid. Now, you probably have heard it more as sulfuric acid because it's going to change the name just to make it sound a little bit better. But that's all it is. Okay. That's all it is. So what about this ITEOUS thing? Remember, I gave you the formula. HNO2, got ahead of myself. H in front means it's an acid category. NO2, I got to name that. That's nitrite if I look on my chart. Okay. ITE would change to OUS. This becomes nitrous acid. And so that's your names, that's your rules for naming compounds. So your homework that I want you to try, you need to find this worksheet. It says chemistry naming test. It's like a last worksheet in one of your naming compounds packet. I want you to do 1 through 20. I want you to try to name these things. It has metals, it has ionic, has molecular, and it has acidic ones in here. The first thing we're going to do on Friday is we're going to go over all of these answers. I can just give you participation just for trying. Wednesday's assignment is going to be these. We're going to learn how to flip this, which is the next video you're going to watch. Okay, so just try these out. Take a picture of these 20, or if you just simply type the name of these 20 into a text box or whatever, that's fine too. All right, that's your assignment for today. All right, have a great day, everybody. Be good.